So it should be in progress now. It's good to see everyone. What are you up to? Any new reading related to artificial intelligence? Any news that you noticed where you thought, huh, that's interesting? Again, at least tangentially related to artificial intelligence. What do you have for us this week? Anyone? I have some news related to a newsletter I get. I thought we'd work through some articles here just to see some things related to the industry. But I'm curious if you've all seen anything of note that you want to talk through or bring to the attention of the others. Jessica started the hands-on machine learning book, my favorite. Let me break this out. Let me find it. I've got too many books lying around here. I need to actually quick put up some of these. So these I had out for logic and basic circuits. Here we go. This is the book. This O'Reilly hands-on machine learning with scikit-learn, Keras, and TensorFlow. Second edition. Love this book. The book is great. So far, so good, Jessica. What do you think? Excellent. I see James has a point in here. I'll read that in a sec. Jessica says, it's good, but I think I need to learn more about the Python libraries. All right. That gives us direction. That gives us something to focus in on. That seems very reasonable. We can work some on the Python libraries and make this will be perfect, Jessica, as you or others. Remember, you all have access to this book. You have access to the book in 1 second through O'Reilly, the O'Reilly Online offering that is actually made available through our local library. So LCC students, you have tons of O'Reilly books that you have access to just out of the gate, and this is one of them. So puts me in a good mood to thank all of the resources that you have access to. Oh, I got to admit someone else here. So, hi, Matt. We just started. I was just asking people if they had, over the past week, seen any resources or news or tried starting any new books related to AI. And Jessica pointed out, Jessica had started the hands-on machine learning with scikit-learn, Keras, and TensorFlow book that I appreciate the most. It's honestly, it's a fantastic resource. James asks, how does a metaverse relate to AI? You know, James, that's a really good question. That's a loaded question. But let's first, who wants to, I've only done a little bit of reading on the Facebook metaverse. How would one define metaverse the way that Facebook is Meta? How would you define it after the readings you've done? Who wants to help me? You can mic up, you can type it in the chat, whatever works for you.
Yeah, so is it like a virtual world almost?
That sounds like an aspect of it to me from the reading I've done. Let's see here. So Jake says, I've been part of Decentraland for half a year now. Oh, whoa, Jake, nice. You have a lot of experience. Virtual space, and then continues on world. So this seems, James and Jake, your insights seem to mesh quite well. Anyone else want to add to this? What other aspects? Anything else we should bring to light when we're considering this?
So I guess Adam, in regards to like the metaverse and it, like I said, because I guess it is a loaded question. As far as AI being related to it, it's pretty much things related to data. Because that's what AI is, so like all the data and the information inside the metaverse, I guess that would be related to AI.
Sure. And also if it, that's a great point. And additionally, if it is a virtual world and there are agents in that world that are not, they're not manned, they're not actually representative of other beings playing the game, but they're actually meant to represent, maybe there's dogs in there, whatever else, that are not actually represented by entities here in the real world. Those agents would likely be leveraging AI to try and represent a real actions, authentic actions that might be taken. Right? So that would be an aspect of how AI would come into play there. I imagine these types of worlds would also leverage AI to try and enrich the experiences of those who are interacting with their world and try and anticipate what they want to see to a degree. Not so that it takes away the autonomy of the person in the world, but so that the idea is if you're creating this type of world, you want people to stick around, you want people to continue to engage. And so there would likely be choices that are made through AI. Anyone else have some other insights related to this? I like this. It's a very interesting topic. So, wait and see. Did someone try and talk there? I don't know if there was a technical issue. Let me see. Let me look at the list. Matt, did you try and talk?
I haven't.
Oh, okay. All right. Just checking. I thought I heard someone try to say something, and well, that was a very nice topic. Now I also see Jessica put it in the chat. Do we need to get into Bitcoin, blockchain, and NFTs? Whoa, doctor. Honestly, I think all of these types of technologies, that could be its own club, honestly. I wouldn't mind doing a session on that just so students are aware of how our club, we're supposed to explore things that are new and unique leveragings of technology. And so we certainly could talk about those. It's actually an interest of mine, but I don't tend to think of those technologies as those that are currently leveraging AI in and of themselves. Now, there are different layers, though. So to be clear, at the base, generation 1 technologies like blockchain, not so much AI. And then you had Ethereum come into play, and that actually leads to the development of decentralized apps. And some of those technologies that are now built on top of tools like Ethereum, they are focused on AI. So we certainly could focus on some of those new offerings that are leveraging lower level tools like Bitcoin, or more specifically like Ethereum. But in and of itself, blockchain's not so much AI, but it is bringing to light several new technologies that are leveraging those tools. I don't know about any of you who's invested in any of these types of cryptocurrencies. I have some assets. I find it very intriguing. And Jessica had some crypto. Jake, it's quite adventurous. It's not for the faint of heart. There are wild fluctuations, but there are some investments that seem, honestly, when you're thinking of an investment, what you're thinking is you see value that's going to come into play in the future. There's gambling, where you're thinking the day traders are going to make a run at this. I'm going to try and buy early, and then I'm going to sell right after it jumps up. But then there's also investing, where you're looking at long-term value. And there's something to be said for this. You can certainly make the case that several of these are contributing. Now, Nick points out, and we can even, NFTs are a great topic, Jessica, the sale of digital assets. Nick points out, you guys are driving up graphic card prices and making them impossible to find. Knock it off. Now, Nick, I want to be clear. There are different forms of cryptocurrencies. So let's not throw all of them under the bus. Some of them are certainly proof of work, and the proof of work cryptos have not helped a lot of that upper end hardware, such as graphics cards, field programmable gate arrays, or ASICs, application specific integrated circuits. Those proof of work protocols, such as Bitcoin, the most well known, certainly have not helped. But there are other mechanisms that people can employ. Cardano uses a proof of stake. That does not require a significant graphics card. And Ethereum, which is the number 2 player in this market, actually does not use, it currently does use proof of work, but it's transitioning. Ethereum 2.0 is transitioning to a proof of stake also. So you won't be able to pin it on them. There are certainly some very significant players in the crypto market that are not, that are transitioning, at least if they haven't already, to proof of stake. And proof of stake does not take a hefty GPU or field programmable gate array or ASIC. It just takes proof of stake. It's about ownership, and then putting your chips in on a particular transaction and saying, yep, I trust this one. So very interesting concepts. All right, you've convinced me. We can do a session on that, because we want to explore all things technology, and the way we can relate it then is we'll talk about cryptocurrencies in general. We'll get to NFTs, and then there are some decentralized apps that are built on top of Ethereum that are actually, I can get my phone. People who want to start playing around with this, just jump into Coinbase. That's one of the easiest ones. I've used several different ones. I've used Coinbase, I've used Kraken, I've used some others too. I'm not pro one or the other, but I just want you to know they're very accessible. And you can use an app like that to actually Robinhood. Now, Robinhood's a little bit different. I shouldn't get down this rabbit hole too much, but the quick on this is Robinhood buys it for, yes, Jake beat me to it. Jake, really good typing right there, I must say. Robinhood holds that crypto for you. You don't actually own it during that time frame. Whereas the others, like Coinbase, you actually own it and you can send it from wallet to wallet. It is yours during that time frame, and you can exchange it with other people through their wallets if you wanted to. Robinhood says, we'll buy it for you, and you will actually you'll benefit from its fluctuations or have issues related to the fluctuations, both up or down. And so oh, I see now some. What about the crypto wallet? I forgot the name. Fox, MetaMask, that one. That is the one I use. There are lots of different wallets. Some of them are focused on particular cryptocurrencies. Some are trying to be more universal. All right, you've talked. I won't go down this rabbit. I could go down this rabbit hole the whole session. But let's plan on having our next session, so that way during the week, you can go find things that you read on and then contribute. Let's have a brief foray into cryptocurrencies next week. And we'll finish that by talking about some of the decentralized apps that are trying to bring AI onto the blockchains out there. Does that sound good? Because I see comment wise, this is, and Jake's like, yay. Let's do that so we can actually explore this a little bit. I want students to know, for instance, that there are different models, proof of work versus proof of stake. And these are very important considerations. Additionally, the proof of stake models typically give you what amounts to interest on what you've staked, and you typically do this without any risk. That is to say, if you stake a transaction that turns out to fall through, you don't lose any of your crypto. So all good things to talk about, all good considerations, and I appreciate you bringing this topic up. Obviously, I enjoy it. Jake sounds like, well, actually has invested and tried out various platforms too. Let's plan on next week. Sorry, I've got a cough. Yes, down the rabbit hole. There's much to do down that rabbit hole. And some of it's basic cryptography. We don't have to go down that too much, though. I don't want people without much of a security background to feel, but we can cover it in general detail so you see what's going on. And yeah, we can dig into the fun stuff. All right. Well, let me highlight, I received several newsletters that are focused on AI, machine learning, that type of thing. And let's work through some of the links I got this week, or actually, I guess it was last week. Again, I very much apologize for the cough. So And cryptography was the bane of my existence last weekend. Was there a CTF that had a crypto challenge, Del? Was it taking people out? Yeah, those can be buggers. I do like those probably the most, though. All right. Here we go. Here is one of the links. Let me put this in. Oh, let me take off all this. All these get before I put it in. And let me put it in chat here so that way you can. So I'm going to put this link in chat so you can all see the same resource. Oh, I did see one other, Adam points out, which by the way, Adam, your name is really cool. There was a quantum crypto question. Oh, did I miss? Oh, that was actually on the CTF. Okay, quantum crypto. Well, then you start to wonder, usually they're worried about the asymmetric encryption algorithms being hackable by a quantum machine of the future. Nice, Del. Well, if you're all looking at this page, whether on my screen or on your own browser, obviously the big companies are making use of various AI technologies. And here we see their favorite deep learning techniques is that what this article tries to put out there. Now, here's a nice little write-up. Let's work through this. Notice here on the screen, right here is where I'm looking right now. This table is, it's nice to see. Some of these are not going to be familiar to you yet, but we can just briefly talk about them. And if, as you're reading the article, please bring things to light that interest you or you have questions related to. I might not be able to answer all the questions. I haven't actually read this before we started today. I'm actually finishing up a bunch of training myself. And so it's been a busy couple weeks, but let's look at this. Here we go. Reinforcement learning. So at DeepMind, reinforcement learning is a big deal. Now, what's reinforcement learning? Do I have my book? I don't have it. Remember, reinforcement learning's this is reinforcement learning and introduction, second edition, by Sutton and Pardo. Reinforcement learning is where it's my graduate school professors likened it to a driver's training instructor who just sits in the car and you do something, whether it's turn on the car, put your foot on the gas, run into a tree, drive on the correct side of the road, whatever. They just either nod, good, good job, or nope. And that's all of their feedback. They either reinforce the good behaviors by letting you know, hey, that was a good job, or they tell you, don't do that again. That was bad. That's all you're getting. So it's in contrast. Remember, we talked about supervised and unsupervised learning, where the supervised, everything's labeled. And you know, for instance, the Titanic data set that we looked at, that's supervised. We could perform some types of unsupervised type of learning on there too. We'd have to ignore the labels. But what we were doing was supervised. Reinforcement learning, you have this world that's been created. Oh, I see, you gotta admit. In reinforcement learning, you have this world that's been created, which takes a lot of work, and then you nod yes or no to that agent in this world, and they learn from that feedback. So very powerful. Actually, you'll remember last week I mentioned this is similar to genetic algorithms. It's just one is interlife and the other is intra-life. The idea is in one, the genetic, something's got to die, and then its offspring go on to learn and do better in that environment. In reinforcement learning, it's that same agent that accumulates this type of response. So DeepMind is leveraging reinforcement learning. OpenAI is leveraging transformers. We're not talking about the terrible movie that was made by, who was the person who was responsible for that? Growing up as a kid, I'll tell you what, I was excited, and then the movie itself, I cannot remember the director. Anyways, this is now going to be up on YouTube. I'm going to be in trouble for saying that, but transformers, what we're talking about, are a powerful new tool that's being leveraged. Oh, there we go. Dell got it. Michael Bay. Yeah, a lot of stuff from Bay that are just, anyways. Transformers, incredibly powerful, being leveraged for a lot of the language related machine learning, NLP, natural language processing. Transformers are where it's at right now. They are hot. They are something you see everyone talking about. We'll read about them a little bit further down here. Self-supervised learning. I've only just briefly read on this. I don't know that much about it, but you see, Facebook's a champion of this, and I'm sure its title gives people more ammunition to give Facebook a hard time. You know, if something's self-supervised learning, that's not helping their case related to what they've been actually in hot water related to recently. Auto ML, we'll actually just jump down there and read that one. Federated learning, machine learning, transfer learning, quantum machine learning. Let's just jump down on the page. I see I've got a lot of other articles to get through here, and then I've got some slides to go through related to artificial neural networks. So let's just jump down here. The transfer learning, though, we did talk about that briefly. Remember the idea that someone, for instance, could have trained a neural net that actually identifies broad classes of things very well, and then you could leverage that and retrain your specific set of data so that it's specific to your particular business scenario, and you're employing transfer learning. You're leveraging what's already been done in that significant. It takes a significant amount of resources to train a large neural net that's focused on, for instance, image classification. You don't have to do any of that. You just take that open sourced neural net and you train it on a small set of your application specific data. So let me clear my drawings. Let's go down here. We already talked about DeepMind reinforcement, but let's just quick look at some of these. So let's read Facebook's. So self-supervised learning techniques. And Facebook believes this is the right path to human level intelligence. It accelerates research in this area by sharing its latest work publicly and publishing it at top conferences. And some of the examples that they give here, Big Red, Textless NLP, and Dino. I'm not familiar with these technologies. I would have to read on these. So maybe we can, in a future session, dig into these. Auto ML. You see Google bringing up here, automated machine learning. This is a little bit more the idea. You can use artificial intelligence techniques to automate machine learning in ways that lead to very good solutions. That's the quick takeaway. Apple, federated learning. Notice the key point here, federated learning is a decentralized form of machine learning. Remember, Apple's pretty big on privacy recently, and that would make sense. If you're gonna be trying to promote privacy to your customers, yet leveraging this type of technology, you would have to find a way to do this such that, again, not everyone's data, everything isn't just pooled into one spot. and processed in that manner. It just says machine learning for Microsoft. I think that's a unfair generalization. Microsoft has been doing quite a broad range of work. But it does have great resources that we're going to work with related to machine learning for beginners. And again, this tab right here, so they have a course, Machine Learning for Beginners, to teach students the basics of machine learning, 12 weeks long. Microsoft has been making a conscious effort to help people get into this area and start learning. I've seen this in the tools they've been making. I agree. Again, transfer learning, we talked about that. And then IBM's a big player in the quantum realm. And here you see quantum machine learning. So it'll be interesting, just an interesting article. It was in O'Reilly's. But let's jump over. Here's another resource. Again, I'll take off you so you're not associated with the email campaign that so remember, when we talk about ML ops, DevOps, who remembers, what does it mean when we're talking about ML ops or DevOps? What does that even represent? Either one of those. Probably start with DevOps, the more general. So Jessica actually puts in, can we have a session about quantum machine learning? Well, if we were going to do that, we would probably have to have one session on quantum computers first, because you look at their architectures lend to different types of algorithms, different approaches. So we would first look at quantum computers, see why they're different, see what they do well and what we're still working on. And then we could say, now that we have that, yeah, we could do that, Jessica. And down the road, I think we can get there. That would be a great idea. I love it when people put ideas in the chat. Please do that. So does anyone? So Dell puts in, actually just puts it straight up. Yep. Development operations and machine learning operations. Think of the olden days when you had a sysadmin managing stuff, and it was local. And you had to, that person was managing the servers on site, handing out the privileges needed to get stuff done. They'd say, hey, you're on this system over here, do your work, all this type. There has to be someone who's managing the local system resources, handling the patches, etc. DevOps, think more along the line, we've moved much of our operations to the cloud. And there's this constant process of ensuring that the pipelines that are needed in the cloud, that includes, pushing code up for testing purposes, running those tests, and then ensuring that the devs actually have access to the resources they need. All of these things tie together in ways where we now just sort of say DevOps when we're talking about people who straddle that line between software engineering and system administration in the cloud. Someone has to straddle that and ensure that all of these pipelines that we need to be working do work. Typically, you have some software engineering experience and you have some sysadmin. Well, what we're finding is that you can't just have DevOps anymore. You need MLOps because they're different enough. These pipelines are, as it says here, these stacks are maturing. You need people who are focused on MLOps. And actually, in some recent talks I've been attending, you hear this mentioned more and more. Here, this article makes the case why data makes it different. And you just read this first paragraph. All ML projects are software projects. If you peek under the hood of an ML-powered application these days, you often find a repo of Python code. If you ask an engineer to show how they operate the application in production, they will likely show containers and operational dashboards, not unlike other software service. But get down to this paragraph, this is where they start to diverge in terms of the case they're making in this article. In contrast, the defining feature of ML-powered applications is that they are directly exposed to a large amount of messy, real-world data, which is too complex to be understood and modeled by hand. That's often the case with big data. It's unstructured, it's messy, and you can't make a nice diagram of your SQL database with its tables and the constraints you're going to put on every column. That's not an option. ML is fundamentally, the stacks that we're having to employ are different. So here, that's a great article. I hope you'll push through just to get an idea. I don't want to take up all our time on this. Here's another article. And again, I'll get rid of you. Get related. Whoops. Here you go. Now, notice this title. You say a new link to an old model could crack the mystery of deep learning. I just want to say this because we're talking about deep learning today. We're talking about artificial neural networks today in the slides. We still don't let anyone tell you that we are crystal clear on why artificial neural networks work well. There is a significant debate as to why they are as powerful and capable as they are relative to other techniques. So it's an interesting, we're leveraging this tool, which isn't quite fully understood. We have aspects of understanding. We know why we need activation functions, etc. But we aren't at a point where we fully understand how everything ties together to create such powerful tools. It's an interesting topic. Now here, this person's presenting, hey, here's a potential new insight. But I point this out because I think students new to this think it's all figured out. And that is not the case in any way, shape, or form. You can be part of this exploration. Maybe you will figure out better why things work, and maybe you can refine what's out there to make a more powerful algorithm. That would be awesome. Here's another article. So who remembers, we remember there was Moneyball? Anyone watch the movie? Yeah, Nick, yes. So think about it. If you're the first one in, if you're the first team to use analytics to make your choices, you have a competitive Dell, and they still lost. Yeah, but things changed pretty quickly. You can't predict away the chaos of a baseball game, but you can overall improve a team pretty quickly if no one else is using it. Right? The first team to use analytics had a competitive advantage. However, I just pasted the link in the chat there. What happens once word gets out? Obviously, you make a movie about it. It's not a secret at that point in time. Then everyone starts using those techniques. And then new, more powerful algorithms come out there, and then people start using those algorithms. And what's happening is it's now created this arms race where everyone is looking for the next most powerful model to try and stay ahead of the others. Dell was giving me grief about the Lions. Look, maybe I will donate. I want to hear, I'm actually going to declare this now. I will not donate my time to the Lions, but I will work with you, Lions. If you'll let me work with you, I will work with the Lions, and we'll bring in artificial neural networks in ways that you haven't dreamed of. We'll do this. Come on, Lions. I haven't given up. I still like, yeah, I gotta believe. So I just point this out. This is a fun read for a little bit people who are a little bit more sports oriented. Have fun. But notice here what they're talking about, Moneyball 3, the explosion of deep learning models. We were analytics, improved our models. Now we're using very large neural networks to make things happen and natural language processing. So good read, check it out. Let's move on. So here, let's just read the top takeaway for this. Oh, actually, let me put the link in. Forgetful Adam, sorry. Just let me. So this particular article says at the top, our lives are dependent on weather. At any moment in the UK, according to one study, 1/3 of the country has talked about the weather in the past hour. Isn't that sad of us? Reflecting the importance of weather in daily life. Amongst weather phenomena, rain is especially important because of its influence on our everyday decisions. Should I take the umbrella? Should we route vehicles experiencing heavy rain? What safety measures do we take for our outdoor events? Will there be a flood? Our latest research and state-of-the-art model advances the science of precipitation nowcasting, which is the prediction of rain and other precipitation phenomena within the next 1 to 2 hours. In a paper written in collaboration with the Met Office and published in Nature, we directly tackle this important grand challenge in weather prediction. This collaboration between environmental science and AI focuses on the value for decision makers, opening up new avenues for the nowcasting of rain, and points to the opportunities for AI in supporting our response to the challenges of decision making in an environment under constant change. So good stuff. Check it out. Oh, and here we go. I see Jake says, I worked for a building supply company. The CFO visited our branch and talked about how they were working on predicting the weather so they could determine when to stock up an inventory and for other reasons. Oh, hey, Jake, very cool. That's exactly, yes, this is good stuff. Now, just because we're leveraging more data, just because we're trying to use more artificial intelligence, doesn't mean things just automatically correct. Here you see US tech salaries grow, but not for everyone. Gender and race gaps widen even as tech booms. This is just think about it. We have all these technologies. We have ways to ensure that we're using great insights, and yet we can't. Something as basic as making sure that there is less of a gap, that's beyond us. It's a good read. We should all be aware of this. And it's neat to see some of the data. And I encourage you to check this out. But at the same time, be aware. This is why ethics and AI we have to always be considering ethical considerations during any work, actually, especially during work with machine learning and artificial, deep learning specifically. We have to be watchful. This article just quick points out, hey, don't equate machine learning with just if you know statistics, you're all set. No, there's quite a difference here. Don't assume that your statistics courses have prepared you for machine learning. They're separate disciplines. They relate. They both can help each other, but they're different. And I appreciate this article. I've actually seen similar. And I won't even get into this one. This was one final article, but given what time it is, I actually want to start talking about artificial neural networks. I have some slides I'd like to talk to. Before I start these, any insights, any articles that you want to share, any questions you have related to anything that you've read so far in those articles, or is there something you would like us to look into? We already know next week we're going to do a foray into crypto because that's fun, and maybe one of you can become millionaires and then invest in LCC and help us, I could use some more bench power supplies, things like this. Anyone have anything? Jake, you were so close. That's how we all feel. I felt like that too. Matt, fund the club. People, fund the club. Yes. I felt that same way too, Jake. I couldn't get into Cardano fast enough when it was down in the I can't talk about that. That's still hard for me. Anyways, I'll move forward. It's hard. It's hard to think about what I lost out on because Cardano, I knew I just had and I couldn't get in fast enough. That was a travesty. Yeah. And if you do the math on what I eventually invested and where I got to stop doing that math in my head. All right. Let me do these slides and we can talk about artificial neural networks. So let me change it so it's presentation mode. So Dell, oh, you say go back, that looked cool. What was I on? Was I on this one? Yeah, this is, so the point is there are a lot of different forms that to artificial neural networks. Essentially, they're graphs. If anyone studied graphs in computer science related courses, you should feel very comfortable if you're looking at these layouts. These different contortions of neurons offer different features. And we'll get to this. This is good stuff. Here we go. Let me switch to present mode, see what happens if I break everything. All right, I didn't break everything. Let me move my chat so I can actually still read it in case you chat me up here. So look, we can't just jump right in and start doing things with neural networks without actually talking a little bit about what they are, why we're using them right now, and their basic functions, how they actually work. I don't need you to suddenly study calculus and to study linear algebra and to study partial derivatives. Don't worry about this. We're going to conceptually try and understand this. And if you have this conceptual understanding, I think you have enough to actually start using them. And then the hope is you'll think, you know what? All right, I'll dig out my old book. I'll do a little bit of the math here when you come up to a problem that merits that type of work, but you don't need to. So let's have a look here. First things first, what's the big deal? Why do we talk so much about deep learning? What has changed? Because there was a point in time where researchers started to look at this and then it was left for dead. The AI winter, so to speak. People gave up. What has changed in our world that has people rethinking deep learning to a point where it's the cool thing? It's what everyone wants to be doing. Moneyball 3.0, deep learning. What's different? Well, there are a lot of things that we should work through, one of which is, well, data. We have tons and tons of data. It's not like days of old where you had to, you'd say, hey, can I get 25 psychology students to come in and do this experiment? And then we'll get really good data on those 25. Yes, I'm so happy. Yes, 25 students. Now you can easily, you could just put a sensor outside my house and I could count cars going by and correlate it with the hour of the day. And I could quickly get tons of data. I could put a sensor at several streets here in Dansville. I would have fantastic data very quickly. With all of the IoT capabilities, all the sensors, all of the storage capabilities we now have, data has exploded. And so we need new tools, right? But as Matt pointed out in the chat, faster, better hardware, Moore's Law. Yes, part of this is we also have a lot more capable systems. We have systems where the GPU in the computer I've got right now, compared to even just 10 years ago, it's mind-blowingly more capable. It's a rate of progress that it's just hard to fathom how much more we can do. And so we not only have seen an explosion of data, but we've seen an explosion of computing power. This has to happen for many of these deep learning advances to happen. And additionally, we've seen improvement in techniques that we use. I know you don't want to be thinking about the math. The math is optional. We're not going to talk about it here, but progress has been made in terms of how we're actually, we can actually strive for better efficiency. We can use better techniques. For a long time, we were pretty limited in terms of what we thought neural networks could do. And then advancements were made. And once they started to happen where you could see there was actually some fruit bearing progress related to all of that labor, then it exploded. Big corporations, if they see there's a potential to innovate, they will throw resources at it. And that's happened. Now, all of those things had to happen. So we had to have a lot more data. We had to have a lot more processing power. We had to make advancements in terms of the math and other techniques that we utilize when we're actually trying to develop artificial neural networks. But there's also an understanding here that the traditional algorithms, this is a generalization. I don't have hard data points here, but this has been something presented by several other people in the industry. And I'm just generalizing. So for instance, Andrew NG makes the same case, but you can see it in data. If you work with traditional algorithms, there's a limit to what you can gain when you throw more data at traditional algorithms. It tends to top out. Now, I'm not quite as bleak. Other people have drawn it so that it actually hits a hard limit here and it levels off to a slope of 0. I actually have it maintain a slight slope upward. I think you can still see some modest improvements as you continue throwing data at traditional algorithms. You can keep training up, so to speak. And additionally, I like to point out this section here. For small data sets, I think oftentimes you can actually, because of how in tune you are with what's happening as a researcher, I think you can see instances where the more traditional algorithm might make sense. So for instance, our Titanic data set. We have an intuitive understanding that we can leverage that sometimes I think gives the traditional algorithm an edge. Because remember, when you're dealing with a neural network, you don't even know why it's making the choices it is. But once you get to a point, so we see as the amount of data increases, we get to a point where the neural network just continues going, improving its performance. It keeps getting better and better and better. Its performance just keeps shooting up. Neural networks have this way of using every little detail you give them. They can harness the complexity of your data in ways, they can leverage that in ways that other algorithms, they can't. So this is one other set of aspects. The idea that in this age of big data, if we can really throw tons of data at something, we can see significant improvements in the performance of our algorithms. Now, some people will tell you, hey, neural networks, we've followed how the cell works, and we've emulated it, we're copying the cell, and that's too strong. Look at this. The diagrams I'm about to show you are not of this sophistication. This is not, you can say it was inspiration. You can say it was motivation for trying this approach. But again, I'm going to cite Andrew Ng again and say what he said on multiple occasions, and then same thing for other instructors I've had. It was motivation, it was inspiration, but they are very different. We can't compare the complexity of what's represented here by neurons in the human body to what we're using and developing in artificial neural networks. But it was motivation, it was inspiration. Now, we started very simply with what's called a perceptron. We have inputs over here. Let me draw accordingly. So here are inputs, can be anything coming into these. And the inputs are weighted accordingly. That's a W, trust me. And they lead into this output, which is a threshold logic unit where it's got some type of function that it actually adds to the decision-making progress here, and then we get an output. Now, the poor researchers who came up with this, I feel bad for them because they did a tremendous amount of work. But once this came out, people poked holes at this and said, hey, this basic perceptron really can't solve terribly complex things. For example, it can't even handle an XOR logical condition. It can't even figure it out for those XOR. XOR is an exclusive OR. It just means if my daughter asks, can I go to the movies and stay the night at my friend's house? I give back an exclusive, or I might say, you can go to the movies or you can go to your friend's house, but you can't do both. That's an exclusive OR. It's one or the other. Well, these perceptrons, they couldn't handle that type of function, and it can only it only has linear capabilities in terms of classification and actually in terms of prediction, regression. Well, what's that mean? Well, let me clear my drawings here. if we're looking at some type of scatter plot, we're looking at some type of data set. What that means is with the perceptron, we're limited to just drawing it has to be a linear breakdown of the data. I'm just drawing a line here and saying, well, half would be, this is one class, this is the other class. That's not powerful. It's not any more powerful than other tools we already had. Not really helpful. And so what happened was people said, these neural networks, these artificial neural networks, whatever, that's not that helpful. Poor people. So it became a ghost town. Artificial neural networks. Everyone left. No one was interested anymore. The pace of research dropped to a halt. And I'm sure people were thinking, that's done. We will never revisit this again. However, some stubborn researchers, I say stubborn because actually Hinton in one of his interviews speaks of himself as being stubborn. So I think it's okay to say. Some stubborn researchers said, you know what, there's something here. We just need to work on this. And what turns out to be the case is that if you make some changes to what we initially had in the perceptron, if you add some additional layers, so here we wouldn't even need more than one. We could just have this hidden layer. Let's pretend this one's not here right now. So we have an input that leads to a hidden layer, and then these neurons lead to the outputs. Let's say that was it. That would be enough to completely change the game. That would be enough to answer, to handle nonlinear classification. XOR is no issue for this type of neural network. In fact, this type of neural network can pick up on any type of pattern. Now, this one in particular, you see that it labels the flow of activation down below here. This is there's a few things we can actually define here. Notice this neuron is connected to that hidden neuron, that hidden unit, that hidden unit, and that one. And then same for this one. This one is connected to all of them. And then this one is connected to every hidden unit in the next layer. This is a fully connected network. That's one aspect. The other is it's feed forward. Notice these work forward to this layer of hidden units, which then work forward to this layer of hidden units, and then finally work forward to the outputs. This is an incredibly sophisticated tool in terms of the answers that it can help us get. Now, there are a few things that have to be happening for this to work the way it does. So let's continue talking about this. One is when we're considering that previous diagram, each one of those neurons, so this is just one of those represented here. Here we have this neuron. Associated with this neuron has to be what's called an activation function. I've graphed a couple activation, just generally what the activation functions look like down here. Here's one. Depending on where it's placed on the graph, this looks like either the tanh, so tangent, or a sigmoid. Just depends where you place it, whether it's from 0 to 1 or from -1 to +1. But they both look the same way. Additionally, the bottom one that's green, that's a ReLU function. For those of you who do know calculus, you know, taking the derivative of a straight line, not so hard. Turns out we don't need some complicated function. It just has to be nonlinear. And the takeaway here, actually, let me delete the drawings. So why do we need this? Well, remember this diagram over here, we could only capture linear classification related problems when we were using the perceptron. We need something that's nonlinear. So in this case, the activation functions, so that we can capture nonlinear relationships, nonlinear patterns. And so this particular activation function, which again, depending on where it's placed on a graph, could either be the tanh or the sigmoid. Don't worry about it. You don't need to know the math related to it. Just know these are two types of activation functions you'll see in this, and they just look like these pictures. That's it. But we need a nonlinear element in these neural networks. Otherwise, they all just collapse. If we had layer after layer and there wasn't something nonlinear, they would just collapse to a linear classifier. They would be very similar to what we use for linear regression, for instance, if we were handling a regression problem. We need something that's nonlinear so we can capture nonlinear. That means if the class was best served by wrapping something like this and then coming around like this, we could. For some reason, there's some theoretical rationale why those dots are the dots that need to be chunked together. We could capture it. Our activation functions give us this capability. So again, coming back here, each one of these has an activation function associated with it. And so there's a weight associated with this particular neuron, and then it has an activation function, and then these combine to then lead to an output for the next layer, in this case, another hidden unit. We have the weight and we have the activation function, and then it eventually makes its way to the output. This feed forward, fully connected artificial neural network, which is a multi-layer perceptron, it is incredibly capable. Let's try and understand the final component to these, though. It's one thing to say what they do when they're working, but how do we train this thing? And this is one of the more complicated things we'll talk about, but I've tried to come up with an analogy that helps. So I'm going to change, there we go. I'm trying to squeeze a little bit more on my screen. So when we're training this, remember last week we talked about loss functions. So root mean squared error, mean absolute error. The idea is you have to know how close are you to hitting the target. And then what you want to do is you want to minimize the output of that loss function. You're trying to find the point where you're as close as you can get to that target. Well, when we're training artificial neural network, one of the biggest advances was coming up with something called back propagation. Let's pretend we're trying to hit this target as a team. And the rule is this player is going to throw the ball. Wherever the ball lands, the next player has to throw the ball, they're each trying to hit the target. So let's watch this once. All right, this one threw the ball. It landed down there. Throws like I do. What's that? Come on. So see, here's where the ball landed. So that's where this player has to now throw the ball from. And let's do this again. They threw again. And this time it lands up there. And now that player has to throw the ball and try and hit the target. They're all trying to hit the target, but they're working as a team. Wherever the ball lands, the next player has to throw the ball. Well, we can actually watch this happen when we're training. And then we can actually, as we're looking at each one of these players, we say, okay, you, let me get my pen here. And this one, you say, hey, you, throw lower and don't throw it quite as far. I'm going to try and coach you along. I think you could have hit that target there. You tend to throw too high and too far. You throw lower. Come on, you got to do better. And you throw higher, throw further. Come on, put some arm into it. We give each one feedback. Each one of these you can think of as part of that hidden layer. One particular hidden layer. And what happens is we look at that layer, we look at their contributions to hitting that target, we give them all feedback. So let's pretend that this is the actual output. They're all tied to the output. We give the feedback, and then once we've done that, we work back to the previous layer. And we do the same thing. So these adjustments are made on the neurons in the final hidden layer. Then the algorithm moves to the previous hidden layer and makes the same adjustments, chaining back. And I use that word chaining on purpose because we're using, if you want to know the calculus behind it, we're using the chain rule, but we chain back and adjust each layer. So let's go back to our diagram. What that means is, conceptually, we look at this layer, we make the adjustments. They are all working as a team to try and hit the targets here at the outputs. We make those adjustments and then we pass back to the previous hidden layer. And we look, all right, you were contributing to, this is that baseball player that threw too short and too high. I look at each of their contributions and I, again, try and help them better hit the target. And then you go back, you work your way back layer after layer. That's back propagation. And you're going to hear that brought up a lot. You're going to hear couched inside of conversations related to calculus and partial derivatives. And don't worry about that so much. All we need to know is that for training purposes, and one thing that I also can bring up here, let me clear my drawings. We start out with random values for the weights. We weight these, we just make guesses. I'm going to make a guess for that one. I'm making a guess for all these. For every edge, making a guess. It doesn't matter. They just can't all be equal, because if they were all equal, think about it. How would we know if they were all equal, for instance, at this layer? How would we know? How could we make any adjustments? The adjustments would all be the same. So we just assign random weightings, and then we start making adjustments in terms of the targets over here. And when I say target, I shouldn't circle these. Actually, what I should say is there's some prediction we're making. And we want to see how close these get us. And then we make adjustments using what I described before, the back propagation. So let's, again, one more time, what happens is we make guesses back here at every edge. We make guesses to get things started. I'll just put a G because I don't want to, you're not going to be able to read it anyway. We make guesses. We work forward. We look at how close we were to the target. And then we work our way back using back propagation and make corrections. Corrections, we work our way back again. And then we do the whole process over again. Just cycle through. So Matt says, do they typically call it pruning of the neurons when you modify according to back propagation? I don't think I typically hear it referred to as pruning, Matthew. But there are cases where you would take, I've seen, there are cases where you would actually remove a neuron from, as a connection. There are different models for sure. In that case, I would expect you would call it pruning. In this case, we're actually just sure, and it could be. I'll look it up later just to make sure I'm not misleading you, but I haven't heard that, and I don't know that I've seen it. I mean, I can quick look. I did get out some text when I was creating these slides. This is Deep Learning by Ian Goodfellow, Yoshua Bengio, and Aaron Corville. Sorry for messing up their names, but I can look in this just briefly and take a peek and see where that comes up. I don't see it in this index, so I'm thinking probably not the term, but in computer programming, when you're dealing with graphs, you certainly do prune. And maybe that's something that, and I shouldn't say in computer science, when we're dealing with graphs. So a few more tidbits here. The last thing I want to leave you with is we just covered one very basic layout. But there are many, many different types of neural networks. We'll only scratch the surface, at least for a while, because, well, we're starting from the basics. But if you're looking here, which one of these looks like a feed forward, fully connected, like which one of, there are a few of these that could fit the bill. For instance, if I'm circling here, this one would be similar. This would have 1, 2, 3, 4, 5 inputs, ends up with 2 outputs. Notice it looks like it's fully connected. That is to say, each subsequent layer is fully connected to each of the previous neurons. This is an interesting approach. We're going to actually cover what are called convolutional neural networks because we want to process images at some point. And convolutional neural networks that's what we typically use when we're working with images. And so we will see we'll see a few different forms, I guess is my point. but that's a ways down the road. And we'll start with fully connected feed forward neural networks, where we just handle some basic data sets that we could handle with other forms of machine learning, such as decision trees. We'll compare the results. So there's my slides. Let me stop sharing. Do the slides help with some of the concepts related to this? Are there things that we should go over in the future? So I see a follow-up. Let's see. Matthew says pruning is its own separate method of training a neural network by adding or deleting connections between neurons or the neurons themselves. Sorry to derail. It's sure it could be. I don't know. It's not something. So you can do most anything when you can make a lot of different choices. But I will say in these two texts, it's not one of the techniques that's specifically talked about. So I want to stick with the more mainstream as we're, so in this text, it just references it in brief, but typically we want to adjust the weights. Now there are techniques we haven't got into. Yeah, when this text speaks of pruning, this is talking about decision trees. There are techniques where we'll randomly, it's similar to pruning when we're trying to protect against overfitting. So just know there are things that actually are analogous to that. So everyone, what time is it? 12:30. Oh my gosh. Let me see what else is here in the chat. Can you share like a Google Doc with all the books that you recommend? Jessica, we should probably have a centralized way of sharing resources. We should look into what would work best for everyone. That seems like a good idea, to have a way for us to share resources. I don't want it to be just where I post things. I would like for you to also. Discord is an option. I see actually Jessica mentions it too. So Dal and Jessica are in on Discord. I'm fine with Discord. Also, I see another comment. Matt, I like the slides as well. I was remembering CPC classification regarding neural nets and pruning and backdrop. We're always closely associated, but we're just different learning methods. Okay, cool, Matt. Let's see. So Jake, I made a server, but I'm pretty noob with Discord. Someone wants to set it up. We could certainly have an AI Discord, and it's a medium that people are already familiar with, so that makes sense. As many of you know, our ethical hacking club here at LCC uses Discord also. So, all right. Nice, Matt. Yes, maybe we could. Well, thank you all for being here this week. Let's work on, maybe next week, look up stuff related to crypto. Let's have a session on crypto, and let's incorporate some of the upper decentralized app capabilities that are trying to leverage AI. There are certainly some, actually you can buy them on Coinbase. There are offerings that are trying to integrate AI right within the blockchain. So it's good to see you all here this week, though. I hope you have a great week. And Actually, Dell, look, someone already, so actually before you go, you can see here, I'm gonna click the link. See if I can get in here. I see an invite. And I don't need the new feature stuff. There we go. Looks like I'm in. Thank you, Dell. Let me go back to the screen so I see everything. Looks all set. Have a great day, everyone. I'll stop the recording now. And I'll stick around if you have questions, but otherwise, yeah, see you next week.